Newton's first law of motion, also known as the law of inertia, is one of the fundamental principles that governs how objects move in our universe. The law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Inertia is the tendency of an object to resist changes in its state of motion. Think of it as an object's stubbornness to change what it's currently doing. A heavier object has more inertia than a lighter one. This means it's harder to start moving a heavy object, and once it's moving, it's harder to stop. Let's look at some real-world examples. First, consider a soccer ball sitting still on the ground. Due to inertia, it will remain at rest until someone kicks it. When a force is applied by kicking the ball, it overcomes the ball's inertia and sets it in motion. Next, imagine a hockey puck sliding across the ice. Once in motion, it wants to keep moving in a straight line at constant speed due to inertia. However, friction between the puck and ice acts as an unbalanced force, gradually slowing the puck down until it stops. Finally, consider a passenger in a moving car. When the car suddenly stops, the passenger's body wants to continue moving forward due to inertia. The car applies brakes and stops, but the passenger continues moving forward until the seatbelt provides the force needed to stop them. The key takeaway from Newton's first law is that forces are required to change motion. Without an unbalanced force acting on it, an object will maintain its current state of motion indefinitely. Forces can be balanced or unbalanced, and this determines whether an object's motion will change. Understanding this concept is crucial for applying Newton's first law in real situations. When forces are balanced, they are equal in magnitude but opposite in direction. The net force equals zero, so the object maintains its current state of motion, either at rest or moving at constant velocity. Unbalanced forces occur when the forces acting on an object are not equal. This creates a net force that causes the object to accelerate, changing its velocity according to Newton's second law. Friction and air resistance are two common forces that oppose motion. Friction occurs when surfaces rub against each other, while air resistance opposes objects moving through air. Air resistance becomes more significant at higher speeds. It's the force that opposes the motion of objects moving through air, like a falling leaf or a speeding car. To overcome inertia and change an object's motion, we must apply an unbalanced force. The greater the force applied, the greater the acceleration produced. Another example is pedaling a bicycle. The force from your legs overcomes the bicycle's inertia and the opposing forces of friction and air resistance to maintain motion. Seatbelts are a perfect real-world application of Newton's first law. When a car suddenly stops, passengers continue moving forward due to their inertia. The seatbelt provides the force needed to stop the passenger's motion. Understanding forces and inertia provides the foundation for more advanced physics concepts. This knowledge leads to Newton's second and third laws, momentum conservation, and eventually to complex topics like orbital mechanics and relativity.